This video is about absolute value inequalities, and it's going to be very similar to solving the absolute value equations that we had. One subtle difference is that we have an absolute value, and remember the absolute value is the distance that something is from 0. So let's say we have an x value here, and like this first equation says, the absolute value of x is less than 3. So we want the distance from x to 0 to be less than 3. So that means that it's going to be this inside interval. So anything between -3 and +3 will give us a distance that's less than 3. Example B is greater than 3, so we want the distance from x to be bigger than 3, which means that it would be this outside interval. Okay, so that's what we're going to take a look at today. So again, the way that we're going to do this mathematically is just write this inequality down without the absolute value bars. X is less than or equal to 3. And then write the absolute value down, only change the sign of the right-hand side and flip the direction of the inequality. So x, it used to be less than, so now we want greater than or equal to, and now -3. And then graph it on a real number line. We have -3 and 3, and it's in between these two. So x is greater than -3, and it's equal to, so we use a square bracket, and less than +3. So it's everything between -3 and 3 is an interval. It would be the interval from -3 up to 3, and using square brackets. In example B, it's the absolute value of x is greater than or equal to +3. Oops, I don't want my number line yet. So first, just write out the inequality without the absolute value bars. So x is greater than or equal to 3. And then x is, reverse the direction of this inequality, so that would be less than or equal to, and change the sign of the right-hand side. So that would be -3. And then we're going to graph it on a real number line. And so it says x is greater than or equal to +3, so that's everything to the right. And then x is less than or equal to -3. So it's everything to the left of -3. So this time it's going to be -infinity to -3, union 3 to infinity. Everything that we shaded. Our next one here, absolute value of x is less than -3. So remember, absolute values have to be positive, so there's no way for an absolute value to be less than a negative number. So this is no solution. Okay, let's take a look at this next one. We have the absolute value of x is greater than -3. And when is an absolute value bigger than a negative number? Always. And so this would be all real numbers. Okay. So our next one here, we have absolute value of x plus 3 is less than 7. So we're going to have two inequalities to solve. The first one is just dropping out those absolute value bars. X plus 3 is less than 7. The second one that we have to solve is going to be x plus 3, and now we reverse the direction of our inequality, so instead of less than, it will be greater than, and then we change the sign of the right-hand side. So instead of +7, we would have -7. Subtract 3 from both sides. For the first one, we get x is less than 4. And for the next one, subtract 3 from both sides, and we get x is greater than -10. Okay, when you have an absolute value and it's less than, we have this situation in our first example where you'll have everything in between your two numbers. If you have an absolute value is greater than, then it'll be these outer two intervals all the time. And you don't really need to remember that. If you graph your answers on the real number line, if you happen to get an intersection like we got here, then the intersection is your answer. If you don't get an intersection, then it's the outside intervals that got shaded. So here we'll have x is less than 4, so it's a round bracket because there's no equal sign, and it's everything to the left of 4. And then here it's x is greater than -10, so we have a round bracket and it's everything bigger than -10, So it's the inside stuff, negative 10 to 4. In our next example, again, just like with the other absolute value equations that we had, you need to get the absolute value alone before you can set up your two inequalities. So that was just like when we had the equations from the last section. So subtract 4 from both sides of this, and we get the absolute value of x is less than or equal to 4. And now you can set up your two equations. You would have x is less than 4, less than or equal to, and x is reverse the direction of the inequality, so that's greater than or equal to, and then change the sign to negative 4. Put these on your number line, negative 4 to 4. So x is less than positive 4, less than or equal to, and x is greater than or equal to negative 4. So it's going to be everything in between the two. So negative 4 to 4 is our interval notation. Our next one, absolute value of x minus 3 over 5 is less than 1. So the absolute value is alone already, so we can set up our two inequalities. X minus 3 over 5 is less than 1. So the first one, remember, is just dropping out those absolute value bars. And then x minus 3 over 5, reverse the direction of your inequality, so that will change from less than to greater than, and then change the sign of the right-hand side, so that would be negative 1. So to solve these, we have to get rid of that fraction, so we're going to multiply by 5 on both sides. That gives us x minus 3 is less than 5, and then add 3 to both sides. We get x is less than 8. Do the same thing here, multiply by 5 on both sides. We get x minus 3 is greater than negative 5, and then add 3 to both sides. We get x is greater than negative 2. So put negative 2 and 8 on your number line. The first one says x is less than 8. The second one says x is greater than 2. Round brackets because there's no equal signs. And it's the interval from negative 2 to 8. So any number inside this interval will give you a true statement in the original. Our next example, again, we have the absolute value alone already, so we can set up our two inequalities. 6 minus 3x is less than 4, and 6 minus 3x, reverse the direction of the inequality to greater than, and then change the sign of the right-hand side to negative 4. Subtract 6 from both sides, we get negative 3x is less than negative 2, and then divide by negative 3. We get x, we divided by a negative number, so we have to reverse the direction of our inequality to greater than, and that's positive 2/3. Here we're going to subtract 6 from both sides. We get negative 3x is greater than negative 10, and then divide by negative 3. We get x, and we have to reverse the direction of this inequality to less than, and that's positive 10/3. Graphing it, we have 2/3 and 10/3. This one says x is greater than 2/3. So it's everything to the right of 2/3. And this one is less than 10/3. So again, it's the inside portion. And it's the interval from 2/3 to 10/3. So any number in that interval will make this a true statement. On our next example, absolute value of x minus 5 is greater than or equal. Again, this absolute value is alone already, so we can set up our two inequalities. X minus 5 is greater than or equal to 8. First one is always just dropping out those absolute value bars. Second one, x minus 5, reverse the direction of your inequality, so that would be less than or equal to, and don't forget to multiply the right-hand side by negative 1, so that would be negative 8. Now we're going to add 5 to both sides, and for the first one that gives us x is greater than or equal to 13. And add 5 to both sides of this one gives us x is less than or equal to negative 3. So we have negative 3 and 13 on our number line. The first one says x is greater than or equal to 13, so that's the outside. and x is less than or equal to negative 3, so square bracket and everything to the left. So our solution is from negative infinity to negative 3, square bracket union square bracket 13 up to positive infinity. Our next one, so we have absolute value of x plus 6 is greater than 7. Before you can set up your inequalities, you need to make sure that you have this absolute value alone. So subtract 6 from both sides. We get the absolute value of x is greater than 1. And then you can set up your two inequalities. X is greater than 1, and x is less than negative 1. Put the two numbers, negative 1 and 1, on our number line. The first one says x is greater than 1, so that's a round bracket and everything to the right. And x is less than negative 1, so that's a round bracket and everything to the left. And our solution then is negative infinity to negative 1, union 1 to infinity, round brackets everywhere because there's no equal sign. Next one, we have the absolute value of 1/3 x minus 3 is less than 2. So we can set up our inequalities right away. 1/3 x minus 3 is less than 2. And 1/3 x minus 3 is greater than negative 2. Add 3 to both sides. We get 1/3 x is less than 5. And then multiply by 3. We get x is less than 15. Over here, we add 3 to both sides. We get 1/3 x is greater than positive 1, and then multiply by 3. It gives us x is greater than 3. Put the two numbers on our number line. The first one says x is less than 15, round bracket to the left. The next one says x is greater than 3, so that's a round bracket and everything to the right. And so it's going to be this inner interval from 3 to 15. In our next example, absolute value of 9 plus 4x minus 3 is greater than negative 2. So first, before you can make any decision about whether there's a solution or not, you need to make sure that you add the 3 to both sides first. That gives us absolute value of 9 plus 4x is greater than 1. So we have two inequalities. 9 plus 4x is greater than 1, and 9 plus 4x. Reverse the direction to less than and negative 1. Subtracting 9 from both sides gives us 4x is greater than negative 8, and then divide by 4. Gives us x is greater than negative 2. And over here, subtract 9 from both sides. We get 4x is less than negative 10, and then divide by 4. And we get x is less than negative 5/2. And putting this on a graph, so just be careful, this is negative 2.5, so that would come first. And this one says x is greater than negative 2, so that would be a round bracket and everything to the right. This says x is less than negative 5/2, so round bracket and everything to the left. So it's going to be the outer intervals, negative infinity to negative 5/2, union negative 2 up to positive infinity, and we have round brackets everywhere because our problem did not have equal sign. Next example, again, we can set this up right away. Our absolute value is alone already, and so we have 11 plus x over 7 is less than 2, and 11 plus x over 7 is greater than negative 2. To solve these, we're going to multiply by 7 on both sides. We get 11 plus x is less than 14. And then subtract 11. Gives us x is less than 3. Here, do the same thing. Multiply by 7 on both sides. We get 11 plus x is greater than negative 14. and then subtract 11. And that gives us x is greater than negative 25. Graphing this on a real number line, negative 25 and 3 are our numbers. This one says x is less than 3, round bracket, everything to the left. This one says x is greater than negative 25, so it's everything to the right. And so it's our inner interval from negative 25 to 3. And that ends our lecture on solving absolute value inequalities. Let me know if you have any questions. Thank you.